Okay, on to page 6. We have number 12, given triangle ABC with AC congruent to BC. So AC congruent to BC. And you know, we have to put all this given stuff in there. Oh, why did I write given? Oosh. Oofa. Triangle ABC with AC congruent to BC. That's my given sentence. We also have CD bisecting BCA. All right, also given. All right, CD, that's this line segment, is going to bisect BCA. So starting at B, we're going to C, and traveling to A. So that's this angle. All right, that's the one that's getting cut in half. So these two angles are going to be congruent to one another. All right, so that's my first conclusion. I can say that angle BCD is congruent. Oh, that was El Terrible. To angle ACD. Definition of angle bisector. All right. Then, in order to draw the conclusion that the two triangles are congruent, we'd have to use our possibilities again. Sas axiom. So I'll write axioms here. We have SAS, ASA, SSS, AAS. The one thing that we don't have is ass or ass backwards. So those two are no good. All right. What I'm going to do is I'm just going to focus on the ones that have a side and an angle involved. All right. Now, unfortunately, that doesn't really eliminate much. All right. It only eliminates side, side, side. But we do know that the reflexive, I almost said refractive, reflexive property would allow CD to be congruent to itself. And then that would be all we need, because now I can go to my SAS axiom, because I have a side, I'll just denote it here, a side, an angle, and a side. I'll just chuck it in there on both sides. Oops, put it in the wrong spot. Side, then an angle, then a side. Side, angle, and then a side. Diagrams get messy, but that's all right. That's what they're there for. All right, so as long as I have that same arrangement, I can now conclude that triangle ACD is congruent to triangle BCD. And that's the SAS axiom. All right. Number 13, DB bisects CA. Both of those are segments. So DB is the knife that's cutting CA in half into two congruent pieces. It's also just flat out saying that DB and, D and B are congruent to one another. All right. So as you move forward in some of these proofs, you start realizing, man, I think the hardest part of this is actually rewriting the given. So DB bisects CA. And you know, I'll just, in this case, I'll chuck in DB is congruent to D, I keep saying that, D and B are congruent to one another. The reason I'm including them in one step here, where I didn't do it in the last one, is because I've actually referred to them in the diagram simultaneously. So why not include them in the same step? It's when I think about them separately that I tend to write them separately. That's more of a me thing than anything else, but you know, it's just a glimpse into the inner workings of my mind. So anyway, step two, well, I have an angle and a side. So just referring back to that list. An angle and a side. So same situation as before. So basically I'm looking for another side or another angle. All right, they did not tell me any information about any other sides, but I have these two good looking vertical angles here that I know are going to eventually end up being congruent. Or they are immediately congruent, but I'll eventually be able to state that they're congruent. So first thing I would state is that angle AED and poor quality and angle CEB are vertical angles. All right, and that's definition of vertical angles. Then as a separate step, I would say that they're congruent to one another. All right, it seems like you could probably jump right to that statement there, but you really can't state that these two vertical angles are congruent if you haven't stated that they're vertical angles to begin with. All right, and so my reason here would be vertical angles are congruent. And then finally, I have, well, if I look at my formation here, or my format, I have an angle, and I have an angle, and a side that's not in between those two angles. So angle, angle, going to the side. All right, so angle, angle, side axiom is going to justify that these two triangles are congruent. Oop, triangle. And there it is.